So as promised, here is a second video on 6.2, which is evaluating and solving logarithms. Now I'm not going to go over the warm-up question number 1 because we already did that in the last video. Let's start off with number 2. Evaluate the following on your calculator. So go grab your calculator. Once you have your calculator, I want you to take a look and see if you can find a button that says log, and I want you to press it and then punch in 1000 and press equals. Okay, so you should get a 3. I'm not exactly going to explain how that equals to 3 yet, maybe in a little bit, okay, but right now I just want to focus on how to put it into your calculator. Other calculators might need you to actually put in the 1000 first and then press the log, then you'll get your answer of 3. Okay, so you just got to figure out which way your calculator works. Once you got that figured out, why don't you do the next one? Log of 100,000. Okay, so I'm getting the answer of 5 and I'm hoping that you do too. Now, this stuff kind of looks a little bit different than what we saw in the last video because there's no equal sign here, there's no number over here. Like, this is not an equation. It's not a logarithmic equation. Right now we're just dealing with expressions, and that's why we get an answer at the bottom. But if I write the 3 at the top, all of a sudden this looks just like the equation we saw before. So this is that logarithmic form that inverse function could be written in that we saw in the last video. And I mean, like, you can see that the y, your exponent, is 3. The answer, your x, is that 1000. Now the base, see, there is a base here, it's just invisible. And I mean, let's explain that right now. I'm going to explain this special case in a second, but the base is not specified. Okay, so sometimes if it's invisible here, you just got to know that there's an invisible 10. It's a base of 10. This is called a common logarithm. Okay, now if there is another number here that's not 10, they'll actually indicate that and they'll put that little letter there. Usually we don't get negatives here. Okay, so b is almost always greater than 0. The reason for that is if I go back to what b actually means, I mean, let's look at the original exponential graph. B was your base, and in this case, b was greater than 1. In this case, b was between 0 and 1. So your base was always in your original function greater than 0. So even when we do a flip and we do the inverse, it's still going to be greater than 0. So we never really get a negative base number, okay? All right, so this is example number 5. We're continuing from the last video. Let's start evaluating or solving each of these logarithms. What you can do is, yes, I suppose you could always put this into your calculator. Some people on their calculators, if they have a fancy calculator, actually have a separate log button where this is, I mean, it says log, and there's a square, like a blank here, where you can input the 5, and there's a blank here where you can input the 25, and you just press equals and it gives you your answer. I think what's going to happen is if your teacher actually tests you on this, you won't be given your calculator because it doesn't tell you, like, it doesn't tell a teacher that you actually know anything if you can just punch these into your calculator. So what they're going to do is they're going to be like, no calculator for you, do it all by hand. Okay, so let me explain how to do it by hand. That's where this special case comes in. Okay, so if I can take the base and make this part the answer part, the same as a base with a certain exponent, my final answer will be the same as that exponent. Okay, so let me just show you. How am I supposed to grab my pencil? I might have to, let's see. Sorry, okay. I'll put the back in a sec. There. Okay, so if I convert this 25 and I go, okay, that's the same base as 5. Okay, so that same base, and 25 is 5 squared, right? So then my answer is that exponent. So that's just going to be 2. That's my horrible handwriting with my mouse. Okay, so that's all you're basically doing in order to figure out the answer. Your calculator is going to spit out an answer of 2 anyway. So you see, it's actually really easy. All right, so answer is 2. The next one. This is 3 cubed. So if I just change that, okay, so 3 cubed, the same base is the 3. This exponent is going to be my answer, so my answer is 3. Another way of thinking about it is 3 to the power, so your base to the power of your exponent is equal to your answer. So 3 to the power of what gives you 27, and that's your answer right there. Okay, so let's just try that out. I mean, 2 to the power of what gives you 1 over 16. That's a tricky one because 1 over 16 is a fraction, which means that your answer has to be a negative because negative exponents give you fraction answers. So 2 to the power of 4 is 16, but then that negative means 1 over the 16. Okay? Now remember, there is a 10 here. It's invisible. All right? So 10 to the power of what answer gives you 0.001? So 0.001, I mean, isn't that 1 over 1,000? So 10 to the power of 3 gives you 1,000, but a negative will give you 1 over 1,000, which is equal to 0.001. You guys getting it a little bit? I mean, let's try a couple other ones. Now remember, what is here? A base of 10, okay? So in this case, 10 to the power of whatever exponent is equal to 125. Let me think. 10 to the power, there is no 10 to the power of something which equals nicely 125. So in this case, I'm actually going to need my calculator because it's a decimal answer. I can't figure that out. I mean, 10 to the power of 1 is 10. 10 to the power of 2 is 100. 10 to the power of 3 is already 1,000, so I'm already over 125. I need my calculator. Okay, so grab your calculator, press log, and then 125, and you should get approximately, so I put that dot there, means approximately equal to about 2.1. Okay, now this one, I mean, like I said, some of you guys have that button on your calculator which gives you a blank here and a blank here, and you can just put in these numbers and you'll get your answer. But let's say a lot of you don't have that button and all you have is a regular log button. What you can do instead is you can go like this. Put log of the big number, so log 20, and then divide it by log 2. Okay, so this will give you the same answer if you don't have a button that looks like this. You should be getting approximately 4.3. So that's basically the video on evaluating or solving logarithmic functions. I mean, you can use your calculator, or it's probably even better just to use your head. Okay, and I mean, rejoice in the fact that this is very easy for now because it's gonna get harder, but that's okay. We'll just be happy in the moment.